Welcome to the R Interview Questions series focused on statistical computing and data science. R is one of the most powerful programming languages for statistical analysis and data visualization. In this comprehensive guide, we will cover essential topics that frequently appear in R programming interviews. The series covers core R programming concepts, including data structures and functions, as well as advanced topics like data analysis and visualization using popular packages like ggplot2 and dplyr. Whether you are preparing for a data scientist role, statistical analyst position, or any job that requires R programming skills, these questions will help you build confidence and demonstrate your expertise in statistical computing. R is an open-source programming language specifically designed for statistical computing and data analysis. It was created by statisticians for statisticians and has become the go-to tool for data science professionals worldwide. R provides a comprehensive statistical computing environment with powerful built-in functions for data manipulation, analysis, and visualization. The key features that make R exceptional include being completely open source and free to use, having an extensive package ecosystem through CRAN with over 15,000 packages available, offering powerful data visualization capabilities that can create publication-quality graphics, and including built-in statistical functions and models for advanced analytics. R also supports reproducible research through R Markdown and has excellent integration capabilities with other programming languages and databases. R has several fundamental data structures that form the foundation of data manipulation and analysis. Understanding these structures is crucial for effective R programming. The main data structures include vectors, which are homogeneous one-dimensional arrays that store elements of the same data type. For example, you can create a numeric vector using the C function with numbers 1, 2, 3, 4, 5. Lists are heterogeneous data structures that can contain elements of different data types, including other lists. You create a list using the list function and can store mixed data types like numbers, strings, and logical values. Matrices are two-dimensional homogeneous arrays created using the matrix function, perfect for mathematical operations. Data frames are the most commonly used structure for data analysis, representing two-dimensional heterogeneous data similar to spreadsheet tables, created using the data frame function with named columns. R supports several fundamental data types that are essential for data analysis and statistical computing. The numeric data type represents real numbers with decimal points and is the default type for numbers in R. You create numeric variables by simply assigning a decimal number like 10.5. Integer data type represents whole numbers and requires the L suffix to explicitly declare integers, such as 42L. Logical data type represents Boolean values true and false, which are crucial for conditional operations and filtering data. Character data type represents text strings enclosed in quotes, used for storing names, labels, and categorical data. Complex data type represents numbers with imaginary parts using the I notation, like 3 plus 2i to check the data type of any variable. You can use the class function, which returns the type of the object. Understanding these data types is fundamental because R's behavior and function compatibility depend on the data type you are working with. Control structures in R allow you to control the flow of program execution based on conditions and repetitive operations. These are essential for writing efficient and logical R programs. Conditional statements include if-else structures that execute different code blocks based on logical conditions. For example, you can test if a variable x is greater than 5 and print different messages accordingly. The if statement evaluates a condition, and if true, executes the code block, otherwise it executes the else block. Loop structures allow repetitive execution of code blocks. The for loop iterates over a sequence of values, such as looping from 1 to 5 and printing each number. The while loop continues executing as long as a specified condition remains true, such as incrementing a counter until it reaches a certain value. These control structures are fundamental for data processing, iterative analysis, and implementing complex statistical algorithms in R. Functions are fundamental building blocks in R that allow you to create reusable code and organize your analysis workflow efficiently. Creating custom functions helps avoid code repetition and makes your analysis more maintainable and readable. The basic function syntax uses the function keyword followed by parameters in parentheses and the function body in curly braces. For example, you can create a simple function called myFunction that takes two parameters x and y, adds them together, and returns the result using the return statement. To call the function, you simply use the function name with the required arguments. Functions can also have default parameters, which provide default values when arguments are not supplied. For instance, you can create a greet function with a default greeting parameter set to hello, allowing flexible function calls. You can call it with just a name to use the default greeting, or provide both name and custom greeting. Functions in R support various advanced features like variable arguments and nested functions. Data visualization is one of R's strongest capabilities, offering numerous ways to create informative and attractive graphics for data exploration and presentation. R provides both base plotting functions and advanced visualization packages. Bar charts are used to compare categorical data and show frequency distributions, created using the barplot function. Line plots are perfect for showing trends over time or continuous data relationships, created using the plot function with type equals L. Scatter plots visualize relationships between two continuous variables and help identify patterns or correlations, created using the basic plot function with x and y coordinates. Histograms display the distribution of a single continuous variable and show data frequency across bins, created using the hist function. Box plots are excellent for showing data quartiles, median, and identifying outliers in your dataset, created using the boxplot function. Heat maps provide matrix data visualization and are useful for showing correlations or patterns in large datasets, created using the heatmap function. These visualization types form the foundation for exploratory data analysis and statistical reporting. ggplot2 is R's most powerful and popular data visualization package, implementing the grammar of graphics approach to create sophisticated and publication-quality plots. It provides a systematic way to build plots layer by layer, making it both flexible and intuitive for creating complex visualizations. To use ggplot2, you first load the library using the library function. The basic syntax starts with the ggplot function, where you specify the data frame and aesthetic mappings using the eyes function. For example, to create a scatter plot using the mtcars dataset, you map weight to the x-axis and miles per gallon to the y-axis, then add geometric points using geom_point. The grammar of graphics approach means you build plots by adding layers. You can combine multiple geometric elements, add smooth trend lines using geom_smooth with method equals lm for linear regression, and customize labels using the labs function for titles and axis labels. This layered approach makes ggplot2 extremely powerful for creating complex, multi-dimensional visualizations with consistent syntax. dplyr is the premier data manipulation package in R, part of the Tidyverse ecosystem, designed to make data transformation tasks intuitive and efficient. It provides a consistent grammar for data manipulation that is both human-readable and computationally efficient. The package uses the pipe operator %greater than% to chain operations together, making code more readable and easier to follow. Core dplyr functions include filter for selecting rows based on conditions, select for choosing specific columns, mutate for creating new variables, and group by combined with summarize for aggregating data. For example, you can filter the mtcars dataset to show only cars with MPG greater than 20, or select specific columns like MPG and HP. The group by and summarize combination is powerful for calculating statistics by groups, such as average MPG by number of cylinders. The mutate function creates new variables based on existing ones, like calculating horsepower per cylinder. These functions can be chained together using pipes to create complex data transformation workflows that are both efficient and easy to understand. Statistical modeling is at the heart of R's capabilities, providing comprehensive tools for analyzing relationships between variables and making predictions based on data. R offers built-in functions for various statistical models and tests that are essential for data analysis. Linear regression is performed using the LM function, which models the relationship between a dependent variable and one or more independent variables. For example, you can model miles per gallon as a function of horsepower using the MT-CARS dataset. After creating the model, use the summary function to view detailed results including coefficients, significance tests, and goodness of fit measures. The plot function on the model object generates diagnostic plots to assess model assumptions. Statistical tests are equally important for hypothesis testing. The t-test function performs comparisons between groups, such as comparing MPG between automatic and manual transmissions. Analysis of variance, or ANOVA, is conducted using the AOV function to test differences across multiple groups, followed by summary to view the results. These statistical tools make R invaluable for research, data analysis, and evidence-based decision-making. R has extensive applications across various domains of data science, making it an indispensable tool for analysts, researchers, and data scientists. Machine learning is a major application area where R provides comprehensive packages for predictive modeling and pattern recognition. Classification tasks use packages like random forest. Clustering analysis employs functions like k-means, and neural networks can be implemented using the NNet package. Statistical analysis remains R's core strength, offering built-in functions for hypothesis testing and statistical inference. Analysis of variance uses the AOV function. Various regression models are available through LM and GLM functions, and correlation analysis employs CORT-test for significance testing. Time series forecasting is another critical application where R excels with specialized packages. ARIMA models can be automatically fitted using ARIMA. Seasonal patterns can be analyzed using Decompose, and the forecast package provides comprehensive forecasting capabilities. Bioinformatics represents a specialized but significant application area where R is widely used for genomics and biological data analysis. The Bioconductor project provides packages for gene expression analysis. Phylogenetic analysis uses the APE package, and sequence analysis employs the Sequener package. Successfully preparing for R programming interviews requires focusing on key preparation areas and following interview best practices. For effective preparation, master core R data structures and types including vectors, lists, matrices, and data frames, as these form the foundation of R programming. Practice ggplot2 visualization techniques extensively since data visualization questions are common in interviews. Understand dplyr data manipulation functions thoroughly, as data wrangling skills are essential for most R positions. Know statistical modeling functions well, including regression analysis, hypothesis testing, and statistical inference procedures. During interviews, follow these best practices. Explain your thought process clearly when solving problems, demonstrating your analytical reasoning skills. Write clean, readable code examples that showcase your programming style and attention to detail. Discuss real-world applications of R concepts to show practical understanding beyond theoretical knowledge. Show knowledge of the R packages ecosystem and how different packages work together to solve complex data science problems. Remember that R interviews often focus on practical problem solving, so practice coding exercises and be prepared to explain statistical concepts in simple terms. Good luck with your R programming interviews.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.